CNC turning machine and precise CNC lathe. CNC stands for computer numerical control. In this machine, we can perform a lot of lathe based turning operations and few milling operations as well. That's why the name is CNC turning machine and precise CNC lathe. In this video, we'll see how to operate this machine and what could be the controls. We will draw this hard copy drawing in the machine and then we will perform the task. So here you can see all the dimensions are given, the complete dimensions. So we'll draw this in the machine. We can use like CAD/CAM, Autodesk softwares, and we can draw the diagrams over there and we can feed it here, and then also we can perform the experiment. But here we will see how to draw the shape in the machine. First you will select the program button here, so it will show all the programs which have already been done, and then we will go for new. So it means we can now go for the new program, and then we will give a name for the program, so it will save under that name. So whenever we want, we can recall it. So then this window will appear. In this window we need to put all the data. Blank means the shape of material which you want to use. Mostly in lathe we use only cylinder, so we will keep it as cylinder. So on the top of the program, if you see, once you move the cursor down, it will automatically ask what does that mean. So in the top, if you can see, it's outside diameter. XO means outside diameter. By the help of down keys in the keyboard, we can go down to the programs for each condition, and from the help button you can refer what does actually that mean. So in the help button, if you press, it will show the dimensions which is actually asked by the machine. So there you can see Z0 point, XO point, ZM point, Z1 point, these all are marked. So on the top also it's showing final dimension, initial dimension, like that. So from these two we can easily fix our data. So Z0 is initial dimension and Z1 is final dimension, and Zm means machining dimension. So Z0 to Z1 is the distance covered including the clamping area, but Z0 to Zm, that is machining diameter. So this is excluding a clamping area. The black region provided on the left is clamping area. And XRO and ZRO are retract of the spindle. So how much it should retract before going for the next layer. And speed limit we can put, that's the maximum speed limit we want to keep. So here it's 3000 rpm. Tool change point XT and ZT are the points where we want to change our tool from the turret. Maybe for example we need another tool at that particular point. So this is tool changing point where we want to change the tool. So in this machine it's kept at 165 for XT and 255 for ZT as default. If necessary we can change it. Then once we are done with all, we can accept. So which means all this data are fixed in the machine. So once you accept, your page and your program is shown on the window. So in the bottom, if you can see, drilling, turning, contour turning, milling, so various these machining operations are there. So first we will select whichever the operation we want. So I'm going to do contour turning, so I'll go for contour turning. Once you press it, in the side window it will appear new contour. Then you press the new contour. So here you will feed the name for the particular operation. So since this is contour turning, I will put CT and then press OK. Then you will get a coordinate point. Z and X axis would be shown there. So there you can draw your diagram. So starting point is asked, X and Z. So we can give these two starting points. So usually we use two coordinate systems here. One is incremental and the other one is absolute. So incremental means you start from your 0 and you will keep on increasing. So which means if your first point is at 5 millimeter, and then when you mark your second point, you will add that 5 centimeter with your second point. So this is incremental. Absolute means you will mark 5 centimeter for the first point to second point, and then another 10 centimeter or something for the second point to third point. In case of incremental, this is 5 plus 10 equal to 15 centimeter. So here I use incremental. It's easy actually. We just have to add up. So here x is the diameter, so that is 5. So you press 5 and then put input, it will feed. And then you accept it. Then it will go to the next point. So in the side window, if you can see, you can have like four arrows. One is showing up to down, one is showing horizontal, one is showing crossword, and the other one is showing a kind of curve. So these four are for contours. So if you want to move up or down towards in a drawing, we will press that particular button and then we will feed the value. If you want to go back or front in the drawing, then we will press that particular arrow and then we will feed the value. And when you select the cross, you need to input the angle also. So my next dimension is 15 centimeter. So I will press horizontal and then I will feed 15. So once you press the horizontal line, it will automatically ask end point Z. So horizontal movement is Z and vertical movement is X. So according to diagram, my Z endpoint is 15 millimeter. So that is 15 and then we will input. Now you can see a horizontal line is drawn. And every time you feed a dimension, you need to accept it and then it will move for the next dimension. Your next step is on the 15th diameter, you are going 1 millimeter up. So that is 6 diameter. So again, we will go for upward arrow and then endpoint of X is asked. So that is 6. So you press 6 and then input. When giving the coordinates, we need to be careful whether it's on positive or negative side. So here the dimensions are on negative side. So it will start from 0 and it's moving on the negative side. So whenever you give these dimensions, be careful of giving the symbols negative or positive. And my next dimension is 26, but we can't give directly 26 over there. Why? Because it's incremental. So which means I need to add the previous 15 with this 26, which means 41. So I'll give minus 41 and then press input and then accept. It will show the line. Then my next dimension is 10. So go up, press the top to bottom arrow mark and then press your dimension. That is 10 mm. Then accept it. Similarly, you go for the rest of the dimensions as well. In case if you give a dimension wrong, you can abort it by pressing the abort key. So it will go back to the previous step. And at last, we need to finish the line from where we start, in the sense of the straight line. So then only the machine will create us a volume. So for that purpose, our starting point and ending point should appear on the straight line, because based on that line, this turning or contour turning operation is going to be made. So the machine will consider that as the norm line. So in this case, the diameter of the workpiece is 5 millimeter. Then on the first step, the increment is 1 millimeter, that is 6 millimeter. And on the second step, the increment is 10 millimeter, so that is totally 16 millimeter. So our end point should be 16 millimeter from the last point. So then you press 16 and accept. So the machine will take that as the reading. Once you feed all the dimensions, you will go for stock removal. So these data are the movement of the tool. So here you can see T, that is tool, which tool we want to use. So here, since this is contour turning, we are going to use a roughing tool. Usually in most of the lathe operations, first we will go for roughing tool, right? And then F is the feed. So here it's 0.15 millimeter per revolution. It can be changed if it is necessary. And V mean variation. So variation in the speed. So if we give variation, we can change the velocity of the machine while doing the operation. So here it's 200 meter per minute. You can give speed without varying also throughout the operation a single speed, so which means S, and we can feed how many RPM, but usually we don't do that. So which means the spindle speed is constant from layer you start to the end. That's difficult in lathe process. So in the variation what we do is at the initial stages we give a high speed, and then when it comes to final stages we'll go for reduced speed. Then the next key is machining. In the machining, if you can see, there are 3 triangles. So usually 3 triangles are symbol for fine finish, that is finishing operation, and for roughing we usually have 1 triangle. So that's a kind of symbol for operation. And then D means the maximum feed per layer. So in each layer how much of material is going to be removed. So here it is 0.75. So it depends on the material. If it is aluminium, we can go for around 2 millimeter per layer. Since the one workpiece we are using here is a brass, we will go for reduced feed, that is 0.75 millimeter per layer. So in each layer the machine will remove 0.75 millimeter layer. And the next one, UX, is finishing allowance. So you can see again from the top. So whenever you change anything in the UX, user D1 like that, it will automatically be shown on the top as what does that mean. So this UX and UZ, it's shown on the diagram also beside. So it's both the direction. UX is on the X direction and UZ is on the Z direction. So what does that finishing allowance means? Before we go for the finishing stage, on the roughing stage, how much of material we want to leave for. Once you set all these parameters, again you accept. So once you feed all the data regarding the workpiece and tool, you can check it as a simulation. How is it going to be performed? So you will press the button on simulation and then you can check. So in simulation, if you see, the ash color area is the initial workpiece and the white color line running in between, that's the final shape. So from this black knob we will increase the feed rate from 0 to 100. So in the simulation it shows how the tool is going to move. Outside of the white line there are some gray space provided. So this was what was given in the finishing, which means so this region is left for the finishing operation. So roughing operation finishes its job. So the certain area left behind, it's left for finishing. So this is what was given in the finishing command. And for this finishing operation you will go back, you copy the same command and then you will paste it, and you will change the operation from roughing to finishing. So which means changing the 1 triangle to 3 triangle. And in the side panel, if you see, you can see from top view, side view and 3D view. So all 3 views are shown. So either we can look in any one of the view, or we can select the third button which can show all 3 views. And then you accept it, and then you can go in the simulation and see what will happen. So now you can observe there are no any work material left beside the white line which is drawn as the final dimension. So this was cut by the finishing operation, the command which he gave as the second phase. And also in the bottom corner we can see the final 3D shape of the diagram. When you give the dimensions, you need to be very careful about the distance between the turret and the workpiece, also from the turret to the clamp. So this distance you set as limit distance in the program. So once you set this as limit distance, the turret won't move beyond that point. In the window you can see the Z endpoint is minus 174, but the workpiece maximum length is around 160. So which means the tool or the turret won't move beyond that point. Okay. In case if you put more than 174, then there would be a problem of clash of tool with the either headstock or with the workpiece. So we can call the tool from keyboard and window as well. For that, first we need to close the door of the machine. We go to the M, that is machine, and then you will select TSM, which means tool. And from the side panel you go to tools, so which shows number of tools which is already installed in the turret. So there are a number of tools and all the dimensions of the tools are given. By changing the arrow up and down, you can select which tool you want to perform the action. So X, Y, so these directions are provided here. We can move it manually. We can perform auto mode as well as manual mode. So here we are now in manual mode, and the arrows beyond they will be used to move the turret in the manual mode. If you on the auto mode, you don't have anything to do with the arrows. You just have to press the auto mode and start. According to the program and your feet, it will perform automatically the action. So on manual mode, by pressing the arrows X and Z direction, we can move the turret. So this tap 1 is for coolant on, and beyond tap 0 is for coolant off, and this one is for compressor on, and the other one below compressor 0 is for compressor off. To removal of chip we use this. This one is for the spindle lock. When we change the workpiece, we'll lock the spindle and then we'll change the workpiece. So how do I do that? I'll press the spindle lock, and then on the screen we can see the spindle lock on red color. So we'll press that, and now the spindle can't move. If we want the spindle to move, then we'll go back to the window and we'll press the unlock button. So now the spindle can move, and this is provided for the manual movement of the axis. So you press this one, and on the window you will select either 1, 10 or 100. So that is the speed which with the axis is going to move. So then we can rotate this knob so that it will move accordingly. So where we will perform this experiment is once the turret moves near to the workpiece. In order to precisely bring it very near to the workpiece, we will use this operation. Because we put the cutting tool near to the workpiece and then we will touch it, right? We will just touch it. So to that fine movement we need this. So in the bottom the axes are provided X, Y and Z. So you press that one, and then when you rotate the knob, it will move accordingly on that axis. And this button is for manual programming mode. So here you can write the program on the screen by itself. So these letters are provided for that, but it's a tiring task. So it's easy to do it in the computer and feed the program, or to draw the diagram here instead of writing the program. So how we will fix the diagram or program from the computer? We will take it in a pen drive and then we will insert in the slot provided. Actually, we are not supposed to stop the coolant since the workpiece is brass and it's hard, and also it will generate a lot of heat. Just for the sake of the video, we just stop the coolant flow for few seconds. This is how the operation is performed.